Okay, it's 12:30, so welcome to Math 1325, Section 4. This is business calculus, right? Math for business. So I'm assuming everyone took Math 1324, yes? Yes, everyone has the prereq for this? I don't know. Looks like we have more people than seats.
That's because I'm not.
Yeah, it's all right. We'll see how it goes. Yeah, they may say no for space, but I don't know. Yeah. Okay. My name is Robert DiGiovanni, right here. Okay, so I am a full-time instructor here, which means that I am on campus more often than if, sometimes you have adjunct instructors who are here part-time, so this is my full-time thing, so I'm available to you. And I'll get into when I'm here once we go through the syllabus. Does everybody know how to get into Canvas? This is the system where we have all of our files and the syllabus and everything else. Anyone having any issues getting into this? No? You're all comfortable? Okay. So one of the most important things here is your inbox. So this is, if I'm going to communicate with you via email, this is where it's going to be sent to your inbox here. And if you send me something, it needs to come through this email system. So don't send me anything through your Yahoo account or Gmail. I won't get it. It gets filtered out automatically. So in the syllabus, it has my email address, but you really don't need that. You just need to be able to use that inbox, all right? So I'm going to assume you can figure that out. And I'm going to switch over to student view. Where is it? Where's student view? Oh, there it is. Okay. All right. So this is kind of, with the exception of this pink little border here, when you go in, this is what you should see. So I'm going to go through this. I'm not going to read word for word the syllabus. I'm just going to highlight the things that are important. First, this little quote I have here. Saw that on the wall in a gymnasium somewhere, and I thought it was a good little quote. Don't practice until you get it right. Practice until you can't get it wrong. Especially with math, this is important because a lot of times students will do a problem and they'll get it right and they'll be like, oh, okay, great. But then they come to the test and they freak out and they do very poorly. You can use this table over here if you'd like. It's probably going to work. And on the test, they freak out and they don't do well. And that's because they haven't gotten to that point where they can do problems repeatedly to the point where they are confident they're not going to get it wrong. The way I'm going to lay out this class, I have a camera in the room. I'll set that up every day. I'll record the lecture, and then I will load it up to YouTube later on today. So you can always go back and rewatch what we missed or what we did. If you miss class, you can have absences. That's allowed. There's a certain number that you're supposed to have. I won't ask questions. Just if you miss a test or a quiz, then you need to let me know. Try like ahead of time. Hey, I'm not going to be in class. I'm a lot more lenient when you let me know, as opposed to just not showing up for a week and a half and then showing up. Hey, what did I miss? So just communication. But I will have the videos there. That way you don't feel like you are completely lost. Now the way to get to those, there's a link right here. It goes to your lecture videos, and right now there's nothing in here. All right. And then you'll be doing homework at home out of a textbook, and I have solutions to those homework assignments worked out, and it's basically me working through the homework problems. Now, I don't have the entire semester. I have most of it, but I still need to do some work, so I'll probably get those updated. By the time you get to the stuff that's not up there, it'll be there, all right? Okay, so let's see. Oh, on those videos, my advice to you would be to try and do the homework by hand, and then if you get stuck, bring up the video and use my video as a guide. Okay, don't just watch the video and be like, oh yeah, I got this. Because it's easy to watch someone who knows what they're doing do math. It's different when you're trying to do it on your own. So use those videos the proper way. Then we have class files. This is where anything I'm going to send to you, any formula sheets, anything that I want to give to you will appear here. Right now, the only thing that's there is the schedule, and that is, let me go back to the home page, that is this one right here. So I recommend that you go ahead and download this to your computer, print it out, and put it in a folder or something and bring it with you. And this just lays out every day what we're going to be doing, and shows when the tests are, when we have a holiday. See, we already have a holiday, right? Next Monday, we're off. And then when our exams are. So this includes the page number and the homework problems that you're supposed to do out of the book. Okay, so I expect that if we cover a topic, that you're going to go home and do that homework, and by the next class you will have that complete. By the next class, not a week later, not 2 weeks later. Now on homework, I do not pick up homework and grade it. You know, I'm happy to go over anything that you have questions on, but you know, the videos are out there, so it doesn't make a lot of sense for me to grade. I may, if I feel like people aren't doing homework, I may ask you to provide me your homework and give you a quiz grade or something, just to try and encourage you to stay on top of it. But this is the whole semester laid out. Boy, it looks like a lot, doesn't it? Okay, and then we have our final exam. So we'll talk more about the final when we get to it. Any questions on that so far? Yes?
For the book itself, if we want to, could we go ahead and show ahead?
Get ahead in the class? Yeah, sure. Yeah. In fact, I do have videos for this class from last semester, or from a past semester. If you ever wanted to watch ahead of time, you could. But I'll let you figure that. My YouTube channel is kind of bloated with information right now. Let me see. So I have, where are all my playlists? I'm too close to the board here. So here are all my playlists. There's a bunch of them here. This isn't all of them, but you could go and search through and try and find this class. All right, and then we have your first official assignment that's due, and this is due before you come to class next time, right, which is Wednesday. And all you do is just click on that, and have you ever gone to like a website and at the bottom it says like I've read all the things, and you just like check it and you don't really read it? That's pretty much what this is. So it's telling it's telling me you have read the syllabus and you understand the requirements of the course. And that way at the very end, if you're like, hey, well, I didn't know that the second exam was worth 20%, I'll be like, well, you kind of told me you did know that, right? So it's just you signing away your understanding of the syllabus, all right? So just click on that, take that it's just a yes/no question, all right? Any questions? Syllabus, shall we discuss this?
What are the grades?
Right here, in the syllabus. Yeah, we'll go through it. So the first part of this syllabus, I am not under any control of this. The college actually forced these into our syllabus this semester. I haven't read this, but apparently it's important for you. And then from here on out, I pretty much have put in here, when we meet, you know when we meet, right, hopefully. And then my information, where I am, I'm located, my office is in this building on the first floor. It's kind of difficult to get to the first floor here. You have to go outside the building, then go all the way down the elevator, and then back in the building. Like there's no stairs that go all the way down. So it's like the basement. So you go over here, room O, and that's where I will be available to you during my office hours, which I'll show you in a second. I do provide my students with my cell phone number. So if you have a question related to math, the way that you can use this is, you're working on a problem at home, maybe you've looked through my homework videos, you're still just confused, or you just can't find your mistake. You can take a picture of the problem, take a picture of your work, and text it to me. And then I have a phone that I can write on, and then I'll kind of like, I'll find your mistake and send you back a picture. And I can help you. That's the best way I can help you electronically with the phone. Now, you can call me if you need to, but it's a lot easier to do it if I have your work. All right? So just make sure that if you text me, that first time you text me, just include what class you're in, what your name, and that way we can start a dialogue together. All right. My office hours. So I'm in my office before this class. I'm in my office at 11 a.m. and I'm there until this class starts. That's on Monday and Wednesday. So if you ever need to come by, if you're not familiar with office hours, that's when I'm supposed to be sitting down waiting for students to come ask questions, which sometimes I get a lot of students, sometimes I don't. Just depends on the students. I can't force you to come get help. But if you need help, that's when I'll be there. Then again, after this class, I'm there for another hour, with the exception of today. Today, I won't be. But starting Wednesday, I will be there after this class for an hour. And then on Tuesday, Thursday, in case you're on campus then, I do have some office hours from 10:30 to 1. And then at Fridays, we don't teach on Fridays normally, so we have like meetings and things. So if you need to meet with me on Friday, I'll be here, but we have to set up an appointment because I don't know what time my meetings are. All right, they fluctuate. All right. Now the book. Does anybody have it? I mean, you have it from the first set. Can you just hold that up? Everybody has that book. This is all the information for it. Usually there's a picture here, but it's the 13th edition. It's a used, you should be able to get that used, so it hopefully is relatively cheap.
It's like 180.
Did you just have to buy it just for this class? Or did you?
Well, it's the same book for 24, so I got it for both.
So divide by 2, that's how much you paid per semester.
Well, it would be more to rent it per semester. I'd be paying almost.
Is it more to rent it?
There was like $20 difference between renting it for one semester or buying it.
Yeah, so it makes more sense to buy.
$10.33. Using it, buying it used is $198. And I got
Yeah, I don't know. Yeah, you know, I don't. The authors of the book, I think is it still Barnett and Ziegler? And yeah, they're the ones who make the money off the book. We don't make money. Yeah.
It's like $20 about like
Yeah. I don't care how you get a book, as long as you can access the problems at the back of the book. Because that's really how I'm going to use the book, is just for the homework sets. So if you can, you know, if you want to go in with a friend and both, you know, split the cost or whatever, you just need it to work the homework assignments. All right, now as far as what we're going to be doing here, you know, this is parts you can read. But let me just kind of sum this up for you. We're going to be doing calculus, and I know that scares people, like, oh my gosh, I gotta take calculus. I'm taking a calculus class. And let me just reassure you that the calculus that we do here is a very, very, very watered down version of what calculus really is. All right, so like I teach calculus, I teach normally, like I don't teach the business classes normally. It's just last spring I taught a 1324, and so I decided to teach 1325. But so normally I teach the calculus, you know, like 1, 2, and 3. So I can assure you that the calculus in here is low level. So don't freak out, right? Just because it says calculus in there. Now we will do calculus, but it'll just be we get the formulas. We try and get an understanding of what's happening, and then we apply the formulas. Now, I'm also not saying that it's going to be super easy. It's just, you know, don't panic yet. All right, so I'll let you read through the outcomes yourself, and now the grades. So standard grading scale, there's no such thing as an incomplete in a course like this. Those are the only options I have in terms of grades, all right? A, B, C, D, and F. And it's standard grading scale. Yes, I will round up, all that good stuff. But the breakdown of the grade is as follows. We have a daily grade. Now, your daily grade is a mixture of any group works I give you, if I ask to look at a homework assignment, any activities I have, any quizzes I may give. And quizzes might be, hey, everyone take out a sheet of paper. I'm going to give you a problem, work alone. Or it might be, all right, here's a couple of problems. Y'all work in groups. You know, the quizzes can come in any form on any day. All right, so just be prepared. Do your homework the night before, or from the class before, and you'll be in good shape. I won't surprise you with anything crazy. And then there's going to be the exams, and we'd have to go back to that schedule. Let me see if I still have it here. Nope, that's the Cal 2. Should still be here. Okay, so we have exam 1, exam 2, exam 3, exam 4, and then a final. All right? So when you're looking at this grade breakdown, this 60% are those 4 exams. So they're 15% each. Make sense? And then our final is 25%. And most people ask, is the final comprehensive? Does it cover everything? And the answer is yes and no. It's not going to be like every single thing we've done. It'll be highlights of certain chapters, but I will give you some sort of guide to help you prepare for that final. Questions on that?
So like, there's not like a lot of homework. You only pick it all up for a daily grade. Like you could just like come to class, pay a lot of attention, do all the work, and like virtually do like very little homework. Like virtually do like very little like side work. Like just do the test. Like you just do really well on the test. Like basically have an A in the class, right?
If you don't do the homework, I would
Yeah.
challenge you to do well in the class. But yeah, I mean the grades. If I start on a regular basis, if I start checking homeworks, then you could potentially have an issue with this 15%.
Yeah, I would do.
But I think the quizzes are really, when this 15% is mostly going to be quizzes, all right? Homework's in there just in case I want to say, hey, look, I'm going to, if I get 3 weeks in and I feel like no one's doing homework, say, bring your homework every single day. I'm going to check it every single day,
It
But
won't be too surprising. Like not too many pop quizzes are like surprise pick up homework. Or will it sometimes be like?
I would expect a quiz at any point in time.
Okay, pop
Yes,
quiz, okay.
yes. I mean, that quizzes will come in any form at any point in time. Now, I'm not going to sit here and be like, they look like they really don't understand this. Let's give them a quiz. The quiz is really just to kind of keep everyone on track. Like, if I give you a quiz and you don't do well on it, that means that you are not at the place that I feel you need to be at this point with the material. So it's just kind of like to just test the waters to when we get to the exam, right?
So do the homework, right?
Yep, do your homework.
Yeah.
Yep. Yes, sir.
For the class schedule, it shows that we start at section 10.1. Is that what we get started?
That's what it says, yeah. Yep. Chapter 10, we're going to start, I think, with limits. Yep. Yeah, this is kind of weird because we go 10, and then we go to 11, then 12. So everything's sequential, 13, 14, and then there's a 13 back in here. So, yeah, we're not jumping around in the book. We're going to go pretty sequentially through it. All right, so policies, blah, 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 blah. So calculators, you need a calculator in this class. All right, you need one. It needs to be scientific, which means it needs to have a bunch of keys that you don't know what they do, right? If you don't know what those keys do, you have a scientific calculator. If it just has like plus, minus, it needs to be more advanced. So it has to be able to do logarithms and exponentials, which in 1324 I'm sure you did. So. And then I don't mind if you use a graphing calculator. I mean, you can if you want, but there's no restriction on that. Attendance, you need to be here more than 4 absences. If you miss more than 4 times, then it's kind of unique the way college works, in case you're not familiar with this. You get 4 free absences, no questions asked. After your 4th one, I can drop you, I can fail you, or I can let you continue in the course, and it becomes my decision at that point. So let's just not get to that point, all right? And we won't have any issues. I just want you to understand that after the 4th one, it's not in your hands anymore, all right? I do have a policy on electronic devices in the syllabus, and I know that you're supposed to sign away a quiz for this. You're going to say yes or no that you've read this, but I need to make sure you understand this. So it's 2018. You're paying to be here, but I'm telling you, you're not allowed to use your phones in class. If you're not happy with that, then you can, I'd be happy to try and get you into a different class, but I don't, sitting there on your phone during class is just not tolerated here. So if you're sitting there on your phone during class, then I will penalize you 10 points on your next exam. So automatically that takes you out of an A. And then you'll be asked to leave and counted absent for the day. And remember, you only get 4 absences. So I don't want to have to make an example out of anyone, but I will, as soon as I see it happen, I'll make an example. So I hope you're not the one. No? Anyone will volunteer to be the first one? No? Okay. I also have disruptive. I don't think this never happens, but just in case we have someone who's really like disrupting the class, same sort of thing. I'll penalize you. The technology thing with the phone. Look, life happens. I understand that, but if it's so important that you need to be on your phone, just step outside. I mean, that's all I'm asking. If you're expecting a phone call and you need to take that phone call, just step outside. That's okay. Just, not 10 times during class, right? All right. All right, the calendar schedule is also in the syllabus, even though you can print it out from somewhere else. Questions? No? Y'all seem thrilled. All right, what else is here? Your grades will be here. Files we've talked about. There's a discussion board, although if you want to talk with your classmates about math, you can come here and do that. And then there's even an free online tutoring. But there's actually 2 tutoring labs across the hall that you can go to. One of them, 308, is open. They've got really good hours. I think they're open on the weekend too, that you can just walk in and get some help. And then 316's right here, and they do a different type of tutoring. Just if you have any questions about tutoring, just talk to me. All right. That's all I have as far as this. Any questions? All right. I think we should get down to business then. I feel like I'm forgetting something though. All right, so what I have for you today is a warm-up, I guess you could call it. This is a day 1 basic skills review worksheet. So this is going to be a group assignment. You get to work together on it, get to start getting the gears going again. And let's see how much we can do here. It's 32 problems. I don't think it's going to be completed here today. So whatever's not completed will need to be done at home and completed. And let's shoot for trying to have this done by next class. Everything on here should look familiar to you. Once I pass it out, you'll see. But what I thought I would do is hand it out, and then they're broken up into sections. So I thought I would maybe like do one problem from each section, and then after that let y'all work together. You know what I'm saying? So that way you have some guide for each section as to what's supposed to happen. Okay. Oh, I think there's one more here. So one of the conversations that I like to have with my students, because you're all business majors, right? No? For the most part, right? For the most part, we have business majors in here. And, there's a question a lot of times about, what's the value of taking a course like this? Like, I'm never going to need this in a real business class, right? Or in a real business application, perhaps. And I would think that argument kind of holds water in some sense. Really, what we're trying to do here, if there's one thing we're trying to do, is we're trying to help you develop yourself as a critical thinker and as a problem solver. That's what this comes down to. Do you have good work ethic? Can you solve problems? Or do you just kind of like, crumble when you get into something that's tough? So it's more about developing you more as a person than it is about can you actually solve a quadratic equation, right? So let's not look too much into that and get down to the deeper meaning. All right, how about number 1? You pick one between 1 and 8. I'll do one of those. Which one do you want me to do?
I want to know if you want negative exponents. Number 3.
Do I want negative exponents?
It's an answer. I want you to work number 3.
Okay, number 3. There we go. So number 3, I'm going to have to aim this projector down. Number 3, you're given 1 over, we would say the cube root of x, right? Do you all agree with that? 1 over the cube root of x. The instructions say to change each radical expression to expressions involving fractional exponents. So to do this problem, you need to be familiar with this formula right here. And this is the formula we use to convert from radical notation. So this root symbol here means radical notation. And this here is a fractional exponent. Right? So whatever the power is here on the x is up here in the numerator, and whatever the root is becomes the denominator. Right? So on this problem that we have here, the first thing I could do is rewrite the denominator. Oh, that's not rewriting it. Oh, there we go. I guess they thought I wasn't going to make any mistakes. Okay, so how could I rewrite the denominator? What you got? X to what power? 1 over 3, 1/3. X to the 1/3. Do y'all agree with that? Okay. So I think this was where you were asking questions. So we have this other relationship, and this may hopefully look familiar, that if you have x to a negative power, that's the same as 1 over x to a positive power. In other words, when we had negative exponents, we would say, oh, you can drop that down to the denominator, right? You know, does that sound familiar? All right, so this formula works both ways. So if we have 1 over x to a power, we can rewrite it as x to a negative power. Yes? So the question was, do I want negative exponents, right? It's not necessarily a matter of what I want. It's a matter of what this course is going to dictate to us, which is we always want in a business calculus class to have our answers where x is up in the numerator, even if it means we have a negative exponent. I know in some of the developmental classes they tell you, oh, don't ever leave a negative exponent. That's not the case here. We actually don't mind them. We prefer to stay away from fractions in this case. So we could actually rewrite that as x to the negative 1/3. And that would be acceptable. Does everyone see what I did there? I'm just taking this right here, this formula. I had 1 over x to the 1/3, and I brought it back up and I made it negative 1/3. Right? You see it?
Is there a reason that we do that for business classes?
Yes, because we're going to be doing something called taking the derivative of this later. And when we take the derivative later, we're going to want it to look like x to a power, not 1 over x to a power. Right? So it's something mechanically we're going to be doing later that will require us to write it like that. Okay? All right. So that's how all numbers 1 through 8 work. Okay, how about something from 9 through 14? You see anything there that 9 through 14 that looks nasty?
I guess you could do 14.
14, negative 5/6 plus 1. Now you might again be asking, like, is there any reason why I'm doing this? Like, and again, later on we will be needing to add 1 plus fractions a lot. So a lot of times later we're going to be doing a fraction plus 1 or a fraction minus 1. So all of this little arithmetic in 9 through 14, just make sure that you are comfortable with this sort of computation. So how do we add fractions? Yep, we need a common denominator. So you first need to realize that that 1 is a 1 over 1, right?
It's actually 6 over 6.
And then you can get a common denominator between these two. So the common denominator is 6, so you multiply top and bottom by 6, right? So we have negative 5/6 plus 6 over 6. And that's, how do you add those? Add the numerator, so negative 5 plus 6 is 1. And then over, what do you do to the denominators? So we don't add them. So it's 6. 1/6. Why don't we add the denominators? Yeah, but why not? I mean, you were told don't add them, right? But why not? Like, just think about it this way. If I have 1 plus 1 half, what's that? Are you saying?
I would say parts of pies.
Yeah, I mean, if you take 1/2 plus 1/2, if you add straight across 1 plus 1, you get 2. If you did 2 plus 2, you would get 4, wouldn't you? and then that would be 1/2, and that kind of doesn't make sense, right? What makes more sense is if you take like a pie or a pizza and you take half of it and you take another half of a pizza and you add them together, you should get 1. And the only way that's going to happen up here is if we left that denominator alone. Just left it as the 2. So we aren't going to get too philosophical. I'm just, again, trying to get us to think through that a little bit. All right, what's next?
Probably like 20.
15 through 17, what do you want? 17? Y'all are just picking the highest number, huh? The highest number must be the hardest one. Remember, this is just review. It's just to get us starting to think again, right? I'm hoping you had a really good summer and so we're supposed to multiply this out, right? The instructions just say multiply and simplify. So how do we multiply that? What do we do? 2, I'll go with you. I heard you say something. Go ahead. You want to do this 2 times what? X. And then, okay, so you're going to do 2 times this x. That's fine. And then what? So you want me to do the 2 times the -4 also? So that's -8? All right. What else do you want me to do?
Then we need to multiply 2x minus 8. We'll FOIL it basically.
Okay, so you're saying that 2 went through here, right? So we got this.
Yeah.
And then you're going to multiply it times this.
We'll FOIL it.
Foil it out.
Yeah.
Yep. I agree. I'm letting you all walk me through the forest here, okay? Yes.
I never really used math terms back in, so FOIL first.
FOIL is a cute little thing that is taught to help people remember, but the technical word for it is called expansion. You're expanding the polynomials. All right, look, okay, so the reason why I'm kind of like going so slow through this is because I'm curious as to why the 2 doesn't go here also.
It's like times 4. It's like the entire thing's times 4 because you already multiplied that by factor.
So so you're saying on one hand I'm allowed to pass the 2 through this one, but I'm not allowed to pass it through this one?
It wouldn't be order of precedence right now. That's where I'm. So you wouldn't FOIL out x minus 4 and 3x plus 4, then multiply everything by 2 because it's on the outer.
Okay.
Is that incorrect? I'm asking.
Well,
It's one of the 2 ways.
I'm asking this question to you because I want to make sure we really understand mechanical operations that are allowed and not allowed, and maybe like why it's that way. So let me try and motivate the idea with this problem right here. 2 times 3 times 4. Okay. If I asked you to multiply this, I think everyone would be comfortable with first doing 2 times 3 and getting 6, and then multiplying that times 4 and getting 24. Yeah? So if we were to break that down, it would be like these 2 together first, that's 6 times 4, and then we get 24. Now, what would have happened had we done that? We would have been 2 times 3 would have been like 6, and then we would have said maybe like times what? 8, and that is not 24, right? So that's pretty much what's happening here. We have like 2 times 3 times 4. And we're going to go the 2 times the 3, right? But not the 2 times the 3 and the 2 times the 4. Do you all see that? Now, another thing I could ask is, would this have worked had the 2 gone to the 4 and then multiply by the 3? So that would have been 2 times the 4 would have given me an 8, and then would have multiplied times 3. That would have given me 24 also, right? So that order doesn't matter. And then what if I would have done something different? Like what if I would have done the 3 times the 4 first, and then times the 2? That wouldn't matter either. So what I'm getting at is a property that we call the commutative property. The commutative property of multiplication. That the order doesn't matter how you do the multiplication. The thing is you only do it once though, between the pairs. So this 2 that went through, that was fine. That was a legitimate move. I don't disagree with that. We get this, and now at this point, we have to multiply these two together. So this is where someone said FOIL, you go here to here, and that gives you 6x squared. Then you go here to here, which is 8x. And then here to here, which is negative 24x. Is everyone following? And then the last one's negative 32. And now we're not done.
We gotta pull 2's of the multiple of all those.
So we could pull a 2, but let's put things together. Do y'all see a spray bottle somewhere around here? Oh, there it is. Thank you. What can we do to that? There's something.
You could simplify 8x minus 24.
Okay, 8x minus 24x. Put those together. What do we call that? Combining like terms. So we could combine like terms here. We could put these two together. They are like terms because they have the same variable raised to the same power. Right? They both have x to the first power here. So we can combine them by taking that number and putting them together. So 8, positive 8 take away 24 is what?
Negative 16.
Negative 16x squared. So 6x squared minus 16x minus 32. And this would be the answer. Now, we could pull a 2 back out. But if we pulled a 2 back out, then we'd be back up here with the 2 out, right? So this worked. Do y'all agree? 2 went through, and then we did this thing. Could we have left the 2 out and done these two together first? So ignore the 2 and done these two together first. Could we have done that? And then passed a 2 through at the end? Yes, and we would have got the same result because the order doesn't matter, right? Okay. Now, on a side note, while we're doing this, that whole cute little thing, FOIL, that I know a lot of you have learned, stands for first, outer, inner, last. First, outer, inner, last. So when we did this multiplication, we multiplied the first two together, right? The first one here and the first one here as first. Then we did this one times this one, so that's the outer ones. Then we did this one times this one, that's the inner ones. And then we did the last ones together, right? You all seen that? I have no problems with that necessarily, but what if I took this problem right here and just changed it a little bit? Yeah, what if I have like 2 terms times 3 terms? You no longer have FOIL. Like that cute little word doesn't work anymore. So how do you multiply that?
You split up the, it's like you're trying every combination, so like 2x times x squared, and 2x also times the negative 3x. Like
Okay.
that first factor times all those 3, and that second factor times all those 3.
Exactly.
Combination.
So that's why I personally don't teach FOIL. FOIL is cute, but I think it goes away from the more powerful way of looking at it, which is you take this one and you multiply it through to everything in the other one. Then after you're done with that, you take this one and multiply it through to every single one there. Which is exactly what we were doing here, right? If I do the first one here and I do this and this, isn't that FO? First and then outer? And then when I do the next one here and here, isn't that inner and last? I mean, it's the same thing happening. So this is more powerful, I think, because you could do 2 times 3 terms, and then you could do 3 terms times 4 terms. We'll get more practice with that later. Okay, I've answered 17. What next? Between 18 all the way, well, 18 to 21. 20? Okay. Is that what you said?
Yeah.
Did you say 20 also?
I said 20.
Okay, is that good? All right, we'll do 20. Two x minus 3 times 5x plus 1 minus x squared minus 3x times 5 all over 5x minus 1 quantity squared. Now, believe it or not, we're going to do some problems in this class later on this semester where we're going to do something and then it's going to look like this when we're done doing something to it. And so what we need to do is just be able to get that last step, which is to simplify this, to clean it up. So what can I do to clean this thing up? This is multiplication right there, right? That's multiplication right here. Yeah, is there anything that looks like we could cancel it?
Yeah, you can get rid of one of the 5x minus 1.
Well, this is a plus 1 though,
Oh, yeah.
right? That's a 5x plus 1, so we can't cancel. And even then, even if this was a 5x minus 1, you would have to have a 5x minus 1 over here also. Like this. Like if you had 4 plus 3 over 8, like you can't say, oh, 4 and then 8 twice. You can't do that because you got that plus 3 here. So you've got to resolve everything up here before you can do that. All right, so if we can't cancel anything, what are we left with then? Just multiply it out. So how about we do that little expansion here? If you'd like FOIL, you can FOIL that, right? And then what can we do on the other parenthesis over here? Can we multiply these two together? Yep. And it's just a 5 would go through to both of those, right? That's it. So let's see what this new numerator looks like. It's going to be this times this. So what's that first term? 10x squared. What's the next term? Plus 2x. Next term? Minus 15. I'll combine them together in a second. And then minus 3. Okay, this next part really trips people up. The multiplication of that 5 through would change this to 5x squared, right? And this times this would be minus 15x. Y'all agree with that? But you have a minus sign out here, don't you? And that minus has to distribute to both of those. So I'm going to put this in parentheses. Now, I'm, again, trying to show all my work. Here's the minus, and then I have 5x squared minus 15x. See, the mistake that a lot of people make on that one is they do that distribution of the 5 through, but they don't put the parentheses, so they just leave it like this. And that's incorrect because that negative has to go through everything that this is. So you need this here. Do y'all see that as a potential issue? Okay. And then all of this is still divided by 5x minus 1 quantity squared. And then I'm going very slow here. 10x squared minus 13x minus 3. That's just combining those two together. And then I'm going to distribute the negative through here. That negative is like a negative 1, so it becomes negative 5x squared plus 15x, then all over 5x minus 1 squared. And we can still do some combining of like terms here. Can't we? This one right here, this one right here, combined together, that's just going to give you 5 of those. And then this with this, it's going to give you what? Plus 2x. And then what do we still have? Minus 3, then over 5x minus 1 squared. Are we done? The next question becomes, can we factor the numerator, right? This is a quadratic. And being in 1324, the class before this, you should have factored quite a bit, hopefully. So can this numerator factor? So how do we check to see if it can factor? I guess my question should be, what is your comfort level with factoring trinomials? Everyone's going to have their own sort of method. And I heard AC method. So I'm looking just over here at this. This looks like just a standard quadratic. How have you learned to factor this? So there's usually 2 techniques. There's usually guess and check, and there's AC, some version of what's called the AC method. So let's talk about guess and check. Guess and check would be you just come in here and try and come up with things that multiply to be this. So like I could put a 5x here and an x here. Wouldn't that give me 5x squared? Right? And then I could start playing around. Let's see, I need a negative 3 at the end, so I could put like a 3 here and a 1 here. Maybe make this one negative and that one positive, so that when I do my last multiplication, I get -3. Did y'all see how I did that? So these two become 5x squared. This and this become -3. But do we get -2x in the middle?
We get a negative 2.
So I would have 5x squared. I would have what? What's that? Minus 15x and then plus x and then -3. That's not going to work, is it? So the only thing I could do possibly to fix that would be to change these signs. Like make this one minus and this one plus. And then maybe it will work. This is guess and check, right? Guess, check. So I just guessed and now I check. 5x squared. Try the next one. 15x and then inside one is minus x and then plus 3. Is that one going to work? That one doesn't work either. Anybody have any other guesses and checks for me to do?
We'll get 3 in your room.
What's that?
Would 5 and 3 work? I'm not even really thinking about it. 5 and 3
5 and 3.
would be plus
Switch the
2 minus 5. Yeah, plus 2 minus 5.
It's still
Yeah,
not going to be
yeah,
enough
yeah,
to
so-
drive the number down.
Sorry.
Switch the 3 and the 1.
What do you mean, put this 3 in that one?
Yeah, yeah.
Yeah, but that's what we did when we switched the signs. That, well, we could do that, but
Then it becomes
3, 1, and then what do you want on the plus?
Negative 1, 3.
Negative and plus. So does that work? Let's see. We have 5x squared. That's this. And then we have 5x minus 3x minus 3. Ooh. Guess, check. Guess, check. So this method is actually somewhat effective once you've done a lot of them. So if this method is not for you, you need another method, right? So the other method I'll show you now. This one works, right? Yes, do we agree? All right, so the other method, again, is called the AC method. Comes from the idea that you take this general form of a quadratic, you multiply A times C. So in our case, what's A? 5, and then what's C? -3. So you multiply 5 times -3, and that would give you -15, right? That's A times C. And then you take the number in front of x, which in this case is 2, right? And this, again, is going to depend on how you learned it. You find these two numbers. And then the way it's taught in most classes, at least here, is that they come up with this little diagram. How many of you all have seen something like that? A few of you? Okay. I need to come up in my brain, right? Somewhere in here, I need to get my neurons to fire to create two numbers that multiply to be this, but add up to be this. So I have to come up with two numbers that multiply to be this, but add to be this. And this still is kind of a guess and check at this point. So what numbers multiply to be this, but add up to be this? 5 and -3. So I put those numbers here, 5 and -3. Now the question is, what do you do with that? Well, the way it's supposed to be taught here is that you write the 5x squared and you put the -3. So these two come down like that. All right, and the thing is this middle term, 2x right here, instead of writing 2x, we're going to write something else. We're going to write 5x minus 3x. How many of you have seen this method? All right. I'm curious because in 1324 you had to factor quadratics, right? Yes? So in this class we have to be able to factor this. We have to be able to break this down to two things being multiplied together. And you need to be comfortable with that. I'm just trying, today's the first day, I'm trying to make sure you have that method somewhere in your toolbox of math tools. If you don't, then you definitely need to get some help on factoring. And that's where the lab across the way can help you with that. Or I can help you on my office hours. All right, I'm at this point. Anyone know what to do with that now? Factor it by what's called grouping. Because we have 4 terms now instead of 3. So we split it down the middle, and we look at the first 2 terms here. So what are our first 2 terms? Do we have a common factor, something that goes into both of these? 5 and x. So I can pull out a 5x, and what would I be left with if I pull or factor a 5x out of both of those? What? X plus 1. Okay, now the goal is on the second 2 terms over here is for you to factor something out that will leave you with an x plus 1. It needs to be exactly this. So what can I pull out of both of these? Negative 3. And you're left with x plus 1. So just check it. This is negative 3x. That's minus 3. It gives us back those 2. And now, what do we do now? Okay, so what we're actually doing is we're seeing that these 2 have the same thing here, right? And so we're actually pulling x plus 1 out. So if you pull x plus 1 out, you have the x plus 1 on the outside. And then what you have on the inside are these 2, 5x minus 3. So it's like if I took this big chunk right here and hit this with it, I would get that. If I took this big chunk and hit this with it, I would get this. And that was the same thing we had earlier, right? The guess and check gave us that earlier? Okay. Irregardless of how you get there, when we're at this line right here, the next line needs to be x plus 1 times 5x minus 3. Now, could I have put the 5x minus 3 here and the x plus 1 here? Could I have switched the order of those 2? Yes, because remember, multiplication, commutative. It doesn't matter what order you do them in. Now, the reason why we have to factor it is to make sure that we don't have any common factors that cancel. In this case, we don't. So we are done. Okay, that was number 20. All right, how about from 22 to 24? Those are factoring problems. There we go. We get more practice. Which one do you want me to do? 24? Okay. If you're given a quadratic, does it have to factor? Does it have to? No, it does not. Okay? Not every quadratic expression factors. That means if you're using guess and check and you can't come up with it, it may not factor. But it is possible that it does factor and you just can't come up with it, and that would just mean that you get it wrong. So, all right, for this one, I'm going to use the table again, the AC method. So I'm going to try and come up with 2 numbers that multiply to be something and add to be something. So what's the number I need them to multiply to be? Right here. Negative what?
105.
Negative 105. And you got that from multiplying 3 times negative 35. And then what number goes down here? 16. And now we get to play the game. We need to come up with 2 numbers that multiply to be negative 105 and add up to be 16. So don't blurt it out. If you know it, don't blurt it out. And it may not work. I just want to run through how you would do this, okay? If I were like struggling with this, what I would do is I get my calculator out, okay? And I would take 105 and I would divide it on my calculator by 1, which of course would give you the same thing, right? So we know that you can get 105 by multiplying these 2, right? But you need it to be negative. So one of these would have to be negative. So imagine I made that one negative, or another case would be to make that one negative. These multiply to be negative 105, these multiply to be negative 105. But what do they add up to be? What does this add up to be if we added these 2? Negative 104, Here, 104. That's not 16, right? So that's not going to work. So those two don't work. Now what I would do is on my calculator, I would divide this by 2. And it doesn't go in, it's a decimal. So I'd move on. I would divide this by 3. What happens if I divide that by 3? What do I get? 35? So I get 35 and 3. One of those has to be negative. See, what I'm doing is I'm testing to see if I can come up with two numbers that multiply to be negative 105, and then I look at what they add up to be. So these add up to be negative 32, positive 32. Still far away from 16, right? So I move on to the next number. I've divided by 1, I've divided by 2, right? I've divided by 3. What would I do next? Divide by 4? 5? Why do I skip 4? Do I skip 4? Because it doesn't go in, right? It's even. So 2 didn't go in, 4 won't go in. All right, so we divide by 5. What's that divided by 5? So 21 and 5, and then I may need one of them to be negative. So I have those two to look at, right? And this pair gives it to us, doesn't it? 21, take away 5, that gives us 16. So what I do here is I put 21 here. I put negative 5. Hey, what if I put negative 5 here and 21 here? It wouldn't matter. Okay, you still get the same result. So now what I do is I rewrite 3x squared here. I put minus 35 at the end, so these two don't change. It's this 16x that gets changed, and it gets changed using these two numbers. So I'm going to write plus what? 21x, and then minus 5x. Now I have 4 terms, and I break them into 2. Notice when I slash them like that, notice that my little slash was on the left side of this negative sign. So right after that second term is where your slash should go. And then you find a common factor for these. So what can I pull out of these? 3x. What are you left with in there? X plus 7. And we need to have an x plus 7 in the other one. So is there something I can pull out of here, these two, that would give me an x plus 7 over there?
5.
Negative 5? It's got to be negative though, right? Because when you pull a negative out, it's going to change the sign, so it creates the x plus 7 in the parentheses. And now at this point, this becomes x plus 7 times 3x minus 5. The good news about factoring is that you can always check, right? Can't you always check your answer? I could always just multiply, FOIL this back out, and I better get this back at the end. If I multiply it out and I don't get that, then I mess something up. Okay. I think I'm going to let you deal with 25 through 27. How about numbers 28 through 29? Which one of those do you want me to do? 28? Is that what I heard? Okay, 28. We end at 1:45, right? Oh my gosh, we only have 15 minutes. All right, so the instructions here are to solve by using the quadratic formula. Quadratic formula. I'm sure you all have that memorized, yes? Have a tattoo of it on your arm?
Is there like plus or minus?
Yeah, let's write it down here. Yes, it does have plus or minus. Okay, so the quadratic formula says that if you have this equation, right? If you have that equation, that we have a formula to give you the answers to this. You don't have to do any work other than plug things in. The formula is negative b plus or minus the square root of b squared minus 4 times a times c, the entire quantity divided by 2 times a. That's the formula.